See Standard 12th Maths, Chapter 6, XI 6.7, Applications of Vector Algebra. So before start doing the problem, I'll give you the introduction of a plane. See, equation of a plane passing through a given point and parallel to two given non-parallel vectors. See, the plane is passing through the point A and also it is parallel to the two vectors. One is vector B is parallel to this side and the other vector C is parallel to this side. But B and C are non-parallel vectors. So that is given for you. So let me take, this is A is a point where whose position vector is vector A. And let me take an arbitrary point P on the plane where its position vector is vector R. So in that case, the parametric form of this plane, equation of the plane is vector R is equal to vector A plus S into vector B plus T into vector C, where S and T are scalars, they belong to R. Come to the non-parametric form. So the equation we represent either in the cross product form or in the dot product form. You collect this A to the left side, vector R minus vector A dot non-parallel vectors. So it is parallel to the cross product of these two vectors. So B cross C parallel to this. So in that case the R minus A dot B cross C is equal to 0. Next is Cartesian form. Cartesian form. The Cartesian form, we take that vector A as a given point, coordinate vector x1i plus y1j plus z1k, vector k, and B vector is b1i plus b2j plus b3k. Vector C is c1i plus c2j plus c3k. So the Cartesian form is x minus x1, y minus y1, z minus z1, b1, b2, b3. C1, C2, C3 is equal to 0. Is equal to 0. This is the Cartesian form of a plane. So let me do the problem. First problem. See the first question in the exercise. Find the non-parametric form of vector equation and Cartesian equation of the plane passing through the point 2, 3, 6 and parallel to the straight lines x minus 1 by 2, y plus 1 by 3, z minus 3 by 1, x plus 3 by 2, y minus 3 by minus 5, z plus 1 by minus 3. See here, so a plane passing through the point 2, 3, 6 they given. That is passing through the point vector A is equal to 2i plus 3j plus 6k. And also the plane is parallel to the straight line. That means here it's parallel to the vector. You can take the denominator direction ratios. So parallel vectors, let me take that as, this is a point, parallel vector. Vector B is equal to 2i plus 3j plus vector k. Then again the plane is parallel to the line here. So in that case it is parallel to the vector 2i minus 5j minus 3k. So therefore the equation of a plane passing through the point and parallel to the non-parallel vectors. They not mentioned you these two are parallel. So parallel to non-parallel vectors. So find the equation. Non-parametric form. Non-parametric form. See, vector r minus vector a dot vector b cross c. So you have to, that is equal to 0. So you have to find what is b cross c first. B cross c is equal to I, j, k vector. B is 2, 3, 1. C is 2 minus 5 minus 3. Simplify this, you will get here I into minus 9 minus 5, that is plus 5, minus j minus 6 minus 2 plus k into vector k into minus 10 minus 6. So that is minus 4i plus 8j minus 16k. Now find the non-parametric form. My dot vector b cross c is equal to 0. So write vector r as it is, minus vector a is here 2, 3, 6, 2i plus 3j plus 6k dot, see the answer here, minus 4i plus 8j minus 16k is equal to 0. So you can keep as it is, or for further simplification, vector r into this. Take dot product, vector r dot minus 4i plus 8j minus 16k. Then minus, take the dot of these two vectors, that is minus 8, 3 8s are 24, minus 16 into 6, 6 6 are 96, minus 96 is equal to 0. So r dot, here you have 4 as constant here, take 4 outside here, 4 into. So minus I plus 2j minus 4k minus, see after simplifying this you will get here minus 8, see just one mistake here, 24, this is 24. So we will get here minus 80, so that becomes plus 80 is equal to 0. Divide the terms by 4. So this 4 here 4. So vector r dot minus I plus 2j minus 4k. When you divide this by 4, you will get plus 20 is equal to 0. This is the answer. Cartesian form. Next is Cartesian form. For Cartesian form, you have to take x minus x1, y minus y1, z minus z1, then b1, b2, b3, c1, c2, c3 is equal to 0. So you have to simplify this. So here our a is here 2i plus 3j plus 6k. Substitute here x minus 2, y minus 3, z minus 6. Then b1, b2, b3. So 2, 3, 1. c1, c2, c3. 2 minus 5, then minus 3 is equal to 0. See, after simplification, this you will get x minus 2y plus 4z is equal to 20. So, this is the answer for you. Next is, I am going to do the fourth sum for you. Fourth sum. See, find the vector, parametric and non-parametric form of equation and Cartesian equation of the plane passing through the point 1 minus 2 4 and perpendicular to the plane and parallel to the line. See here, the point is given for you passing through the point, the plane passing through the point. So, vector A is equal to 1i minus 2j plus 4k passing through the point. And parallel to the vectors, we need to get two parallel vectors. See here, the first one is, it is perpendicular to the plane. Our plane is perpendicular to the plane. So, this plane is in the Cartesian form. It contains the vectors, that is the coefficient of x, y, z is the vector. That is your parallel vector. Coefficient of x is 1i plus 2j minus 3k. So, this is the parallel vector of our line. And again it is parallel to the line. So, therefore, the denominator are direction ratios. So, we will get the parallel vector as 3i minus 1j plus vector k. So, therefore, equation of a plane passing through the point vector A and parallel to the two given vectors. First is parametric form. Parametric form. So, parametric form is vector R is equal to vector A plus S into vector B plus T into vector C. So, substitute the points. Vector R is equal to, point is I minus 2j plus 4k plus S into B vector, vector I plus 2j minus 3k plus T into vector C, 3i minus j plus vector k. So, this is the non-parametric form. Next is non-parametric form. Non-parametric form. Non-parametric form is vector R minus A cross, dot vector B cross C is equal to 0. So, in this case, you have to find B cross C and then you have to take a dot on this. In order to do this simplification for non-parametric form, first let me find the Cartesian form. Cartesian form. Cartesian equation. So, x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 is equal to, so substitute the values. X minus x1 is 1, y minus y1 minus 2, so plus 2, then z minus 4. B1, B2, B3, 1, 2, minus 3, 3 minus 1, 1 is equal to 0. Let me do the simplification. I have not done the previous sum, so you follow this. X minus 1 into 1 2s are 2 minus plus 1 plus 3, 4. So, 2 minus 4 minus y plus 2 into, leave off this, 1 1s are 1, 3 3s are 9, minus 9, so plus 9 plus z minus 4 You leave up this row and column, you will get minus 1. 3 2s are 6 minus 6 is equal to 0. Simplify this, x minus 1 into minus 2. X minus 1 into minus 2. See here, one small mistake here. X minus 1 into 1 2s are 2, 1 3s are 3. Written minus 4. Just changes minus 3. So you will get here 1 minus 1 minus y plus 2 into 10 plus z minus 4 into minus 7 is equal to 0. Simplify this, you will get minus x plus 1 minus 10y minus 20 minus 7y plus 7y. Then minus 4 into plus 7 is plus 28 is equal to 0. So minus x minus 10y minus 7z. Simplify this, 29 minus 20 is here, you will get plus 9 equal to 0. See, all the x, y, z variables are negative values. Change the sign for all the terms. So x plus 10y plus 7z minus 9 equal to 0. That is, just you can keep as it is. So this is your Cartesian form of the equation. Cartesian form of the equation. We are not yet given the non-parametric form in the dot product form. So just you convert this Cartesian form into non-parametric form. Both are same. So non-parametric form. You have to represent this in the dot product of the vectors. See, take x, y, z. So that is equal to vector r dot, the coefficient is I plus 10j plus 7k. You take this 9 to the other side is equal to 9. So we represented in the dot product form. So instead of calculating all this, you can directly give this step, r dot vector I plus 10j plus 7k equal to 9. This is the answer. Parametric form and non-parametric form and then Cartesian form. Thank you.